Assalamualaikum warahmatullahi wabarakatuh. My name is Afiq bin Amiruddin. My number metric is s71667. Today I am going to present about 4 different methods to prevent corrosion. So before I share about the methods of preventing corrosion, I would like to share about corrosion. What is corrosion? So, corrosion is a natural process where metals deteriorate due to reactions with their environment, such as exposure to oxygens, chemicals, and moisture. Corrosion can weaken the metal and structures. Also, it can damage the equipment. And it can increase the cost maintenance. So, to avoid the corrosion, we have to do several prevention methods that we can do to avoid the corrosion. For the first methods that we can do to avoid corrosion is protective coatings. Protective coatings are one of the most common methods of preventing corrosion. This technique involves applying a barrier over the metal surface to shield it from corrosive elements like moisture, oxygen, and chemicals. For the example of these methods, which is protective coatings methods, is doing paints and varnishes. If we do paints and varnishes, we form a thin film to avoid the metal from exposed to air and chemicals. We can see in our daily life many people use these methods to avoid corrosion. As we know, people do paints on their gatehouse, such as my house. I also paint on the gate, which is a steel gate, to avoid corrosion. But this method is not a long-term method. That's all I can say. And the next example is galvanization. Galvanization, which is a process where metals, especially steel, are coated with a layer of zinc. Galvanization is similar to other method to prevent corrosion, which is catalytic method, but I will explain about the catalytic method after this. And lastly, powder coating. Powder coating is a dry coating that applied electrostatically and cured with heat, forming a durable protective layer. And the benefits of doing protective coatings is it is not as expensive than other methods, and it can provide additional aesthetic benefits through coloring. But protective coating can wear out over time, which is it will peel off little by little, time by time, and coatings is a poor application or damage to the coating can leave the underlying metal exposed. For the second method is catalytic protection, which is catalytic protection is an electrochemical method that prevents corrosion by making the metal a cathode in an electrical circuit. There are two types of methods in catalytic protection, which is sacrificial anode protection, and impressed current catalytic protection, which is more known as ICCP. For sacrificial anode protection, a more reactive metal such as zinc is attached to the structure. The metal corrodes preferentially, sparing the protected metal. For impressed current catalytic protection (ICCP), an external DC power source is connected to provide a constant protective current, reducing corrosion on larger structures. Such as example, this method ICCP used in offshore platforms and large storage tanks. In catalytic protection, sacrificial anode protection, which is we have two metals and we use zinc as the anode in this method. Then the zinc will sacrifice itself to be corroded first to protect the original metal. Catalytic protection is highly effective for buried and submerged structures. Catalytic protection is a long-lasting protection when properly maintained. As the limitation, this method sacrificial anodes need periodic replacement. An ICCP system requires constant monitoring and maintenance to ensure the optimal operation. And for the third method is material selection and design. Choosing corrosion-resistant materials and incorporating smart design principles is a proactive approach to prevent corrosion. In material selection, we have stainless steel, aluminum and titanium, and non-metallic materials. For stainless steel, it contains chromium, which is a layer that passive from oxygen, which is it makes stainless steel immune to rust. And for aluminum and titanium alloys, naturally resistant to corrosion in certain environments. And for non-metallic materials, we have plastics and composites that are immune to corrosion. And for design improvements, we can avoid creating crevices or gaps where moisture can accumulate. And we can design surfaces to allow proper drainage and prevent water pooling. For lastly, we can isolate dissimilar metals to avoid galvanic corrosion, where one metal corrodes faster due to contact with another in conductive medium. And for benefits for material selection and design, this method reduces corrosion risk from the outset, and this method requires less maintenance over the long term. And for the last method is environmental control. Environmental control involves modifying or managing the surrounding condition to minimize corrosion potential. This is often applied in controlled environments such as industrial processes or storage facilities. And for the methods, firstly, we have dehumidification, which is this method reduces moisture levels in environment, and it can preventing condensation and rust. Secondly, we have corrosion inhibitors. Corrosion inhibitors contains chemicals that are added to water or other environments to reduce the rate of corrosion. For example, inhibitors are commonly used in cooling water systems in industries. And for the thirdly, we have pH control, which is this method maintaining neutral or slightly alkaline pH in environments like boilers or pipelines reduces corrosive reaction. And lastly, oxygen removal. In closed system, removing dissolved oxygen from water prevents oxidation. This method is cost-effective in controlled environment and can complement other methods like coatings and catalytic protection. Among the 4 methods that I have been explained, I choose one of them as the best method that we can do to prevent corrosion, which is material selection and design. Material selection is the foundation of corrosion prevention. Corrosion-resistant materials are selected based on their chemical properties, mechanical performance, and ability to withstand specific environment conditions, which is, if we choose stainless steel, we can be more confident that our material that we use can avoid the rust or corrosion. It goes same as aluminium and its alloy. Aluminium forms a natural oxide layer when exposed to air, and it making corrosion resistant. We also have specialized alloys, just like nickel alloys and titanium alloys, which is 2 of them is resistant material to high temperature and chemical environments. The design is also important thing to prevent the corrosion, which is the design of a structure plays a crucial role in preventing corrosion, which is poor design can lead to conditions that accelerate corrosion, such as water pooling, crevices, and areas of high stress, which is we can do the structure design by avoiding the crevices and put the best drainage, isolation of the similar metals, and reducing the stress concentrations. The advantages of the methods is the materials and designs that we choose is resistant to corrosion, increase the longevity of structures, and reduce maintenance costs. And it also can proper selection reduces the need for replacements, minimizing waste. And for the safety, the structure remains structurally sound, avoiding failure caused by corrosion. And this method also cost effective, which is, although initial cost may be higher than the other methods, savings on repairs and replacements justify the investment. And for the conclusion, the choice of corrosion prevention method depends on the application, environmental conditions, and budget constraints. Protective coatings are versatile and widely used but require regular maintenance. Catalytic protection is highly effective for submerged and buried structures, while material selection and design help prevent corrosion at the root level. Finally, environmental control is ideal for control settings like industrial processes. In practice, a combination of this method is often employed to achieve the best results. For instance, protective coatings can be used alongside catalytic protection to enhance durability or corrosion resistance. corrosion resistant materials can be paired with design optimization to minimize long-term risks. And by employing these strategies, industries can effectively mitigate the costly impacts of corrosion. Thank you. So that's all from me, and I'm sorry for the gibberish talk because I have ulcer in my mouth. So that's all from me. Thank you.